Dear students, under the lecture series on complex analysis, here we are going to solve problems on the topic harmonic function and analytic function. The first problem says that prove that u is equal to 2x minus x cube plus 3xy square is harmonic and find its harmonic conjugate. Also, find the corresponding analytic function. Now let us first prove that the given function u is harmonic. So by the definition of a harmonic function, we know that a function u is said to be harmonic if it satisfies the condition uxx, that is double partial differentiation of u with respect to x, plus uyy is equal to 0. So we shall first prove that the given function u satisfies this Laplace equation. This equation is known as Laplace equation, and if our function satisfies this equation, then it is said to be harmonic. So as the first step, let us prove that the given function satisfies this equation. For this, first we shall take and write the given function u. The function u is given as 2x minus x cube plus 3xy square. Now we shall find each of this. So now first we shall find ux. So ux is the partial differentiation of u with respect to x. So when you partially differentiate this, differentiation of 2x will be 2 because the differentiation of x is 1, so 2 comes as it is, minus the differentiation of x cube is 3x square plus y square will be treated as constant, so 3 comes as it is, and the differentiation of x is 1, so y square comes as it is since it will be treated as constant. So therefore the differentiation of u with respect to x, partially with respect to x, is this. And we should also obtain uxx. So we should further differentiate ux in order to obtain uxx. So the differentiation of 2 is 0 minus, here differentiation of 3x square, 3 2 times is 6x plus, and this is 0 because it will be treated as constant. In a similar way, let us find uy and uyy. So uy is the partial differentiation of u with respect to y. So the differentiation of 2x will become 0 as x will be treated as constant. In a similar way, the differentiation of x cube is also 0. Now here we have to differentiate. So 3x is a constant, and further when y square is differentiated, we get 2y. So the differentiation of the u with respect to y gives us 3 2 times is 6, so 6xy. Now again we have to differentiate this with respect to y. So uyy will be equal to, now with respect to y we are differentiating, so 6x will be constant, so it comes as it is, and the differentiation of y is 1, so we get uyy to be equal to 6x. Now we shall apply in this Laplace equation. So what happens? So we see that uxx plus uyy is equal to, what is uxx? Minus 6x. And what is uyy? It is plus 6x. So minus 6x plus 6x render as 0. So therefore we get uxx plus uyy to be equal to 0, and hence the given function u has satisfied the Laplace equation, and therefore u is harmonic. So the first part is over. Yes. Now after this we have to find the harmonic conjugate of u. So now u we have proved that it is harmonic. We have to find the harmonic conjugate of u. So second part. So let us do that. So let the function v be the harmonic conjugate of u. Then by the definition of harmonic conjugate, we know that this will imply the function f of z, which is equal to u plus iv. This function will be analytic. So is analytic. This is by the definition of harmonic conjugate, where the function u is harmonic and v is the harmonic conjugate of u. So now in this we have to find the function v, so that we will be finding the harmonic conjugate of u. For that we are going to make use of the CR equations. That is the first CR equation we are going to make use of. We know that there are two equations which correspond to the CR equations, out of which we are going to make use of the first equation now. So the first CR equation is ux is equal to vy. So we are going to make use of this CR equation in order to find the harmonic conjugate of u, that is v. So how are we going to make use of this? Now we have already found ux. You making use of that, we can equate it to vy. So what is ux? Ux we have found here. If you see, ux is equal to 2 minus 3x square plus 3y square. So we can write that vy is equal to 2 minus 3x square plus 3y square, because we know that vy is equal to ux. So that I am going to write now. So therefore vy is equal to ux. So ux is this. So 2 minus 3x square plus 3y square. So now after equating, from this, using this, we can find the function v by integrating this vy with respect to y. So let us integrate this with respect to y. So integrating on both the sides with respect to y, we get here what we will have: integral vy dy is equal to integral 2 minus 3x square plus 3y square dy. Now we have to integrate on both the sides. Vy, when integrated with respect to y, we get v, and that is equal to. Now we shall integrate this with respect to y. So what is the integration of the constant 2 with respect to y? So 2 comes as it is, and the integral dy we will have, which is y. Then this minus 3 is a constant which comes as it is. X square will also be treated as constant since we are integrating with respect to y. So x square also comes as it is. So we will be having integral dy, which is y, plus, now here 3y square we have. So 3 is a constant, it comes as it is. Integration of y square will be y power 3 divided by 3, plus a constant of integration we will have. Now since we are integrating with respect to y, the constant of integration has to be written with respect to x. So we will be having phi of x as the constant. So this is what we obtain after integrating on both the sides. So further rewriting this, I will cancel these two 3's, and so finally v will be equal to 2y minus 3x square y plus y cube. Since I have cancelled this 3, we will have y cube plus the constant of integration phi of x. So this is what we obtain as v. Therefore the harmonic conjugate we have obtained, but we have to note that we have a constant of integration phi of x. So now this constant has to be eliminated. In order to eliminate this constant, and this constant is with respect to x. So now in order to eliminate this constant, we have to differentiate v with respect to x, and we have to eliminate this constant. Let us see how we are doing that, so that we can substitute the constant over here and obtain the harmonic conjugate v. So patiently if you listen, you will understand. So from vy we have found the function v. Now since there is a constant of integration, we want to eliminate this. For that we are going to find vx, and we will use the second CR equation. So I will show you that. So I have taken and I have written here, and let me mark this as some equation 1. Now we have to find this phi of x. Now in order to find phi of x, first we have to differentiate equation 1 with respect to x. So what we get? We get vx. So that is equal to, differentiation of 2y will become 0, because partially we are differentiating with respect to x, and this will be constant. And what is the differentiation of this term? Minus comes as it is. 3 comes as it is. What is the differentiation of x square? It is 2x. And y comes as it is. And the differentiation of y cube is 0 because it will be constant. And the differentiation of phi of x with respect to x will be, so plus phi dash of x. So therefore rewriting it, Vx will be equal to minus 3 2 times is 6. So 6xy plus phi dash of x. So this is our Vx. Now we are going to make use of the second CR equation. So by the second CR equation we know that Uy is equal to minus Vx. So we are going to make use of this. Now in this we shall substitute what is Uy. What is Uy? We have already found Uy previously. That is Uy is equals to 6xy. This is what we obtained as Uy. So we shall substitute that. So from this what do you get? 6xy is equal to, what is minus Vx? Minus of Vx is this. So we shall substitute that, minus of minus 6xy plus phi dash of x. Now we're rewriting this. What do you get? 6xy is equal to, minus into minus becomes plus. So 6xy then minus phi dash of x. Now from this, taking this phi dash of x to the left and taking the 6xy to the right of this equation, we get phi dash of x to be equal to 6xy minus 6xy, which is equal to 0. So therefore we obtain phi dash of x to be equal to 0. So from this we can say that phi of x will be equal to some constant c. So that we know that differentiation of constant is only 0. So since phi dash of x is equals to 0, we obtain that phi of x must be a constant, and we take that constant to be equal to some c. Now we shall substitute this phi of x in our equation 1. So when we substitute phi of x as constant c, what do we obtain? We obtain this v. So v is equal to 2y minus 3x square y plus y cube. And what is phi of x? It is constant c. So plus c. Therefore we have obtained the harmonic conjugate v of the given function u. So this is how we have to do. Now in order to find this harmonic conjugate, we are making use of the two CR equations. Got it? So we are done with the second part of the question also. So the only remaining part is also find the corresponding analytic function. So we have to find the corresponding analytic function. Already we have taken the analytic function f of z to be equal to what? U plus iv. If you see here, f of z is equal to u plus iv is the analytic function. Now in this function we have to substitute the value of u and the value of v in order to find the analytic function. So let us do that now. So now in order to find the analytic function, we know that the analytic function f of z is equal to u plus iv. Now what is u in that? U is, we have here 2x minus x cube plus 3xy square. So we shall substitute that. So it will be 2x minus x cube plus 3xy square plus I multiplied with v. What is v? We have obtained here. So 2y minus 3x square y plus y cube plus c. So this is only v. Now we shall rewrite this in such a manner that we can make it in the form of z. So how shall we do that? Now if you see here, 2x we have here, and here we have 2y I. So when we combine this, 2 can be taken in common so that we will get x plus iy, so that we can replace it by z. So this is equal to, now if you see here, I will show that term separately for you. So when we combine 2x, so this is 2x plus I multiplied with 2y. Now this, when we write separately, we can take this 2 in common and we can write it as x plus iy. Now next what we have, now these terms we will separate as real part and imaginary part and we will write. So now in this term we have minus x cube and then plus 3xy square. Now this term how I am going to write is, I am going to take this minus out so that I can write it as x cube minus 3xy square. Now then we have already taken this 2y out, so don't worry about it. Now these are the remaining terms. Now I am going to take the minus out from this term, so it will be minus I multiplied with, so this will become plus 3x square y and then minus y cube, and we will multiply this I with c and write separately as IC. Now if you see this, you will be able to identify what are these terms, because I will show you that. We know that z is equal to x plus iy. And what is z cube? We have already learnt about this. It is x plus iy the whole cube. On expanding this using a plus b the whole cube formula, we get x cube plus 3x square iy plus 3x iy square plus I cube y cube. Further, that will be equal to x cube plus I 3x square y, and then here we will be having I square which will be minus 1. So minus 3x y square. And what about I cube? I cube I already told you, it can be written as I squared multiplied with I. The value of I square is minus 1. So it will be minus I. So this will be minus I. So minus I y cube. Further, combining the real part and imaginary part, if you see x cube and minus 3x x cube minus 3xy square, and then I plus I multiplied with 3x square y minus y cube. So this is the real part and this is the imaginary part. Now if you see here, we have x cube minus 3xy square, and when we take this negative in common, we will be having plus I multiplied with 3x square y minus y cube. So it can be written as minus z cube. So that is what we obtain here. So therefore this becomes, this 2 we can take in common and we will be having x plus iy, and here this minus can be taken in common and we will be having x cube minus 3xy square plus I multiplied with 3x square y minus y cube and plus IC. So therefore this will be equal to 2, and what is x plus iy? It is equal to z. So 2 is z minus, and this whole term can be replaced as z cube and then plus IC. So this is what we obtain. So therefore the f of z that we have obtained is f of z is equal to, so what is f of z? This is what we obtained. 2 is z minus z cube plus IC. So this is the corresponding analytic function. So I hope you would have understood this problem. It's a very significant problem in the examination point of view. Kindly go through each step patiently. You will definitely understand it. For more problems under the topic harmonic function and analytic function, follow the upcoming video lectures. Thank you.